YOLO.
Everybody say good morning.
Morning.
I don't know why we're on page 2.
YOLO.
All right, we're going to start transformations today. Like I said, we're going to need some graph paper for this. Okay? A transformation, that's what goes in this first blank. See if you can spell it right, even though it's written right above it. A lot of letters in that transformation. Takes up almost the whole alphabet. A transformation. Okay? What happens if you're transformed?
Turn
Turn
into
into
something.
something different.
Yeah,
Like
turn
a
into
frog.
something different. You move. Okay? A transformation is an operation that maps an original geometric figure called the, got a name. Okay? The original geometric figure is called the pre-image. That's what goes in that next blank. Okay? What's an image?
A picture.
Picture. What's pre mean?
Before.
Before. Okay? So, it maps an original geometric figure, usually a triangle, a quadrilateral, something you can graph, and the pre-image is the before picture onto a new figure called the
Post image.
you would think it'd be post-image, but it's just considered the image. Good use of your words, though, Matt. Okay, so onto a new figure called the image. We're going to talk about those. All right, today we're going to do just translations. A translation slides a figure from one position to another without turning it. Okay, tomorrow or the next day we're going to, not tomorrow, but later in the week we're going to start turning figures. Then it gets tricky. Today's stuff, guys, will be a piece of cake. Easy. All right, watch how we do this stuff. Okay, we got some of you guys still kind of get confused when you graph points because of all the work we did with slope. Okay, slope was the change in y over the change in x. But graphing points, guys, and jot this up at the top, remember, a coordinate or a point is x comma y, where the x goes first. And I've actually seen kids above their coordinates write x and y, so they know which number goes with which variable. Okay? So, graph, what's that little symbol in front of the ABC?
Triangle.
Triangle. ABC. Notice there's 3 vertices. With vertices A at 4, -3, B's at 0, 2, and C's at 5, 1. So you're going to have to graph those points and then make a triangle. And then you're going to graph its image, because that's going to be the pre-image. You're going to graph its image after a translation of 4 units left and 3 units up. So the triangle, guys, is going to slide. It's going to move. It's going to be real easy. Okay? And then write the coordinates of the image. Okay. Let's do this. All right, so A is at 4, 3. So start at the origin, guys. X is 4, Y is -3. 1, 2, 3, 4. 1, 2, 3. We're down in quadrant 4. Graph it and label it. Point A. Always have to label your points when you do translations. You'll see why in a minute. All right, B is at 0, 2. When one of the values is 0, kids get all bent out of shape. Where is 0, 2?
Up 2.
Up 2. It's not on the x-axis. It's actually on the y-axis, okay? Because, think about it. We go x, we go start at the origin, we go 0 units x, on the x. So it's still going to be on the 0, but then we're going to go 2 units up and label that point B. So be careful, guys, when one of the values of your point is a 0, because it's a common mistake. And then C's at 5, 1. 1, 2, 3, 4, 5, 1. C. And then you don't have to use a straight edge. Just do your best to make a triangle. Connect your points. Here's my triangle. Now, I got the luxury of having different colors. This will make sense. All right, we're going to graph its image after a translation of 4 units left and 3 units up. We're going to do both those for all 3 of those points. We're going to move those points 4 units left and 3 units up. And let's do this in an organized way. Start with point A. Everybody put your little pencils on point A and go 4 units left. 1, 2, 3, 4. And 3 units up. 1, 2, 3. Coincidentally, we landed on the origin. Did everybody land on the origin?
Yes.
Yeah.
Just a coincidence. That's not going to happen very often. Guess what the name of that new point is?
A.
Can't be the same.
A1.
Close.
A2.
A2.
No. It's called A with a little with a little hash mark, dash, hash mark, dash, and it is called A prime. Everybody say A prime.
A prime.
That's how you label the new point when it gets translated. It's A prime. Now, do the same thing for B and C. Go 4 left and 3 up. I'm going to do B next, organized way. 1, 2, 3, 4. 1, 2, 3. Guess what the second point is called? B prime. Everybody say it.
B prime.
B prime. You got to label it B prime. Just put a little hash mark on it. And then try to find C prime. 4 units left. 1, 2, 3, 4. And 3 units up. 1, 2, 3. C prime. And then connect and make that triangle. What's true about the new triangle, A prime, B prime, and C prime, compared to the old one? Is the one thing you notice? It's congruent. Very good. Is it the same size, guys?
Yeah.
That is every translation. It's going to be the same size. What else? Go ahead, Harrison. Say something intelligent.
They're different colors.
Oh, very good. Thanks, Einstein. Go ahead, Ange. What do you want to say?
It's the same type or the same shape.
It's the same shape. It's not only the same size. It's the same shape. Very good. What do you notice?
They cross over each other.
They cross over. Do you think that'll always happen?
No.
No. We could move it a little bit more and it wouldn't be an opposite. You know what I mean? So not every time it's going to cross on top. That's one that does. All right. We did say write the coordinates of the image. So I'm going to go A prime right here. Okay, you got to label your new vertices. Someone raise their hand and give me the point of A prime. Come on, every hand in this room should go. If you don't know that point, you're in trouble. Phoebe. 0, 0. Very good. It's the origin. Somebody give me B prime. What are the coordinates of B prime?
4, 5.
No.
Negative 4, 5.
Negative 4, comma 5. Because X went negative, people. And then do C prime. 1, comma 4. Remember X, comma Y. So that's all you're doing for your homework, guys. Is you're gonna move things based on how they tell you to move them. Somebody guess how many problems you have for homework?
6.
6.
Really?
Really? All right, let's do this. Graph, triangle, X, Y, Z. Last period got all bent out of shape with this because it was X, Y, and Z, and the coordinates are X, Y. Get it?
Yeah.
If you want to change them to triangle ABC, might be better. But you don't have to. If you're smart enough to deal with X, Y, and Z, and then a coordinate is X, comma, Y, those two X's have nothing to do with each other. They're just together. No, I got the graphs are done for you on the worksheet.
Yes.
All right, so you're going to graph triangle XYZ, and then you're going to graph the image after each translation. We've got 2 of them here. And then write the coordinates of your new vertices. So X, negative 4, negative 4. So I'm going to go negative 4 and down 4. And that's going to be point X. Okay, Y is going to be at negative 3, negative 1. Left 3, down 1. That's point Y. And then Z is at 2, negative 2. Go back to the origin. X2, right 2, down 2. And that's Z. Everybody draw a triangle, guys, and it should be in the same exact spot I have mine. You guys all good?
Yeah.
Okay. Everybody translate this one 2 left and 3 down. And label them correctly. So I'm going to start at X, 2 left, 1, 2, and 3 down. And what's the name, guys, of the new point?
X prime.
X prime. And then Y, 2 left, 1, 2, 1, 2, 3 down. There's Y prime. And Z prime is 2 left and 3 down. Z prime. Connected?
It's really easy.
How many people got the same exact shape and size? Right? On a translation, that's going to happen. What if you do a translation, guys, and it's different?
Did it wrong.
You did it wrong. You didn't do something right. Okay? Let's label the points. X prime. Gracie McGuire, what are the What's the point x prime now? -6 comma -7. Okay. Ooh, little foreshadowing. You guys like foreshadowing?
No.
Look at point x. -4. Look at point x prime. Look at the numbers, how he translated it. 2 left. What's -4 minus 2?
-6.
What's 3 down? Down means that. What's -4 minus 3?
-7.
That's always going to work.
So we don't even.
So, keep that's tomorrow's lesson. Somebody rattle off y prime for me. What's the coordinates of y prime? Go ahead, Miss Catherine. -5, -4. Somebody verify that?
Verify.
And then z prime. Ooh, be careful. That's one's on one of the axes. Who can do z prime? Go ahead, Trace.
0, -5.
0, -5. Sounds good to me. Notice 2 minus 2 is 0. -2 minus 3 is -5. All right. Graph your original one again. You know, the blue one. Do the same thing over there. And then let's go 3 right and 4 up. You can do this, people. So we're going back to the original. X is -4, -4. Label it. -3, -1. There's y. And then z is at 2, -2. Make your triangle. Wait, hold on. How come that doesn't look in the same spot as the first one? Yeah, the graph is different. Okay, the origin on that first one was top right. It was more in the middle of the second one, so it's not in the same spot. We'll go 3 right and 4 up. X. 1, 2, 3, 4. There's x prime. 3 right, 4 up. 3 right, 2, 4. There's y prime. We have 2 of them on the axes. Am I doing that right? Then z prime. 1, 2, 3. 1, 2, 3, 4. Your shape's the same, guys?
Yeah.
Sweet. Okay, practice labeling the points. X prime, y prime, z prime. Miss Harms, what's x prime? -1, 0. Very good. Okay. Tara Burke, what's y prime? 3. Well, count of 3 up. 0, 3. Okay. And Mr. Devon, what's z prime?
6, 2.
Then count carefully. 1, 5, 2. I got it. 5, 2. Notice 3 right and 5 up. If you add 3 to the x values, you get the new x value. And if you go add 4 to the y values, you get the y values. We're going to do that stuff tomorrow. Catch on to that pattern now. All right, last thing. Let's fill out a little graphic organizer. We're in the process of making something that's going to help you guys remember this stuff. All right, in your own words, guys, this is a transformation. Jot that word down. It's not up here. This is information about a transformation. No, not a transformation. A what? Translation. Transformation is the whole thing. Thank you. Translation.
It says it in the middle.
Oh, it says it in the middle. Aha. We didn't see that first period. All right, define it in your own words.
Really?
First period's a lot different than you guys. That's why I tape you guys. They are dead asleep. They don't say a word for 50 minutes. It's great. A slide that doesn't turn or flip. That's what we're going to start doing here later in the week. We're going to start turning these things and flipping them. Okay? You guys know what would be the word for a flip? Reflection, right? Mirror image, it's a reflection. Like when you look at yourself in the mirror. Okay? It's a reflection. It flips. Those three characteristics. Here's three things we wrote down. 1, same shape. All those triangles stayed triangles. Matthew?
Same size.
Same size. Very good. And a third thing that the book says, which I think they're being redundant about
color.
saying 1 and 2, they wrote that the faces is the same way. I think that is being the same size and same shape.
Yeah.
But they wrote that down. Same size. All right. Draw an example, guys, of a translation. So do your best to take this triangle that's already drawn, draw it the exact same size and shape, just up and to the right a little bit.
Wow.
Okay? There's an example of a translation. Same size, change, it just slides, it moves. Okay? And then draw an example of draw a non-example of a translation.
Done.
What would happen?
Circle.
Okay, draw a circle.
Square.
It, like,
A mirror image.
Or it flips. Yeah, let's do, and it's bigger or smaller. Watch this. We drew this last period. This one. That's not a translation. That's actually a rotation and a dilation. Okay? We don't think you're going to get into dilations this year, but you're definitely going to rotate things. You're going to move them. And that's it. The rest of the thing is for tomorrow. Do not lose those notes. Okay? Signing off, guys. Everybody say goodbye.
Goodbye.